Welcome back to Savage Fabrication. Bradley Carter, behind the camera, Dalton Carter. So I'm owner operator, and he works for me all the time. So we've been talking a lot about real vague or broad things, just to help everybody kind of understand what's going on. So this time around, we're thinking about doing a injection pump series, and we're going to do each video or part 1, part 2, part 3, even if it's on a single injection style. We're going to do it VE, P700, and VP. I'm not going to go in the common rails. We could do a short one, but I really don't know enough about them to speak about them. We could probably get a real maybe base video for how the common rail injection system works. I do not understand the HUE system at all. It doesn't make a lot of sense when we can fire injectors with fuel, or an injection pump, or even now common rail. So that's my take on it. Nothing against the Ford guys. I just don't understand the HUE system at all. It seems to cause more problems than it fixes. So this one's going to be on the VE pump, and the technical term for the VE pump is the Bosch VE44. We just all call it the VE because there's only one style that ever came on the trucks, and it's the same thing with the 24 valves. And us saying VP, the actual technical name for the pump, is a VP44, but we can communicate with each other just saying VP. So in this video, this might be multi-part to maybe shorten the videos down. We kind of saw, we don't know if we want to go too long form, or maybe kind of shorten it up a little bit. It might be easier to listen to and help us keep producing videos by just splitting them up into smaller sections. So this one might be a multi-parter just because we do have a VE44 right here, as well as we're going to go over the baddest pump that's been across my dyno, which is the Hungry diesel pumps. Those things just rip. So if you're looking for the most awesome VE44 pump, VE pump you can get, those things have laid down the highest numbers on my dyno to date. So, and with that, which was really cool, with going with a built one from him, which we've never got from any of the other built ones, is we actually got a CCs per RPM sheet, which our P700 should come with. Often they don't. You just have to ask the builder to get them. And we talked about getting those things in previous videos. They normally give you a max CCs. Yeah, I bought this pump. In this case, the guy say bought the pump and it's 310 CCs, but if he didn't know the pump was 310 CCs at 2200, and we're making peak power at 3000, but we're only making 270 cc's worth of horsepower, even though the builder told him it was a 310, we would be scratching our heads. Our math would essentially have to be made wrong on purpose for our numbers to be correct. But once we know cc's per RPM, we go and look in and we say, hey, the thing's not getting up to the boost target that we need by the RPM that we want to get to burn the available cc peak, which is down at the low end. So that's why it's really important to have this stuff. We've actually only got it with VE pumps. So same P pumps, we always get this big CC number, or we get a CC number, and it's really hard sometimes to get a CC per RPM type of deal, because that is how it works in mechanical pump. Faster you spin it up to a point, the more CCs it puts in a minute. So we do have a real one here. I think we're going to start the video off with just going over the VE pump, do's, don'ts, and how far you can modify them. To my own knowledge, we'll give out some of the secrets. Honestly, we kind of kept them, the guys that know the stuff, kind of secret for a long time, but the things have been out so long, and it's such a small niche thing now. It was more common back when I was in high school, early late college area, where I was starting to get into these. They're still pretty common, but nowadays they become extremely less common. Even as far as how to do mod videos and stuff like that is really old school, and there's things in those videos that I tend to disagree with. So we're going to go over all the do's and don'ts and some of the little trade secrets that might help you out, given and willing that you're willing to possibly destroy the injection pump. So there are some mods that we call one-way mods, where we do the mod and there's no going back. So we'll go over some of those. At least there's no going back without sending it to a shop, or in some cases no going back without buying a new pump top, AFC top. So we can go over some of those things, some of the things that I did back in the day to get more rip'ems out of my VE pump. 40 plus pounds of boost on a non-bench pump Seems to be actually pretty decent. We're doing like the gauge went to 43 or went to 40 pounds, and we would just go around it and peg the backside of it. The thing eventually killed the H1C. Just shoved the turbine housing, or sorry, turbine wheel through the backside of the thrust bearing. So that happens with those things. So for our next part, we're going to go down to our injection pump here, and we're still going to go over terminology and what everything is and how it works. So here's our VE pump. This is a intercooled version. Externally, I guess there's one difference. There are no differences up here other than the way the feed line comes in. On a non-intercooled, the feed line comes over the pump top half. It's a real pain to take off, and then which I think comes around the front. It's been a long time. Then on intercooleds, it comes back around here, so it's a lot easier on an intercooled truck to access this stuff. It's all still doable. It's just a little bit more a pain in the butt in a non-intercooled setup. The other difference, and only difference to my knowledge externally, is going to be the delivery valve thread pitch is different. The delivery valve internally is actually different as well, but we're just talking external differences. The thread pitch on these is a different thread pitch. Small shaft, I want to say this is 44 foot-pounds on the torque. I believe that's correct. Do not over torque these. Do not think it's a P pump if you torque it. Higher than 50 foot-pounds is probably the absolute max you want to go. I want to say book spec is 44 to 48. If you go above this, it is very easy to strip it. It is a key-weighted pump shaft, so there is nothing fancy going on here. It's impossible to screw up the removal and install of these things as long as the gear inside the case is not lifted up and shifted a tooth. That can happen, so if you do pull the pump out and then turn the engine over, make sure that the things line up. I want to say it's the 0 on the cam and the D. It's the E or the D. I'm pretty sure it's the D on the pump gear. Need to line up. I could be wrong. Don't take that for all that it's worth, but I'm pretty sure it's the D that needs to line up with. E, I believe, is advanced one tooth. And that might be backwards. So that's that. So what we're going to do is, this one's already slightly taken apart. So the big thing that gets messed up the most, we have to say, when modifying these things, even still have a hard time with them, is indexing the throttle shaft. So this big hex, I'm going to just pop this off. Oh, a really easy mod. Move your ball for your throttle linkage over one hole and then adjust the rod length. This is going to allow you to pull the throttle over further, and also you need to remove, or at least reset, the throttle stop to the new location. You can just remove it if you want. I do not understand why there's a throttle stop on a linked system that has no spring set up in it, where you're just going to end up beating the crap out of your linkage. So honestly, you could just take it off. So here is what I call this the Cog system. So we have our indexing marks here. We have a female cog, and then on our throttle arm there is another set of cogs. Before this comes off, it's highly recommended that you mark this. And even still with it marked, if you do change out a governor spring, there's a chance that it's going to have to change location. Generally speaking, with the 366 3200 spring, it goes back in the same spot. Sometimes it needs to go one cog forward or one back, but most of the time it's going to go back in the same spot. This does have a little slot on it for you to see. One of the mods that you can do is, actually we'll get to that later, but that's that. I'm going to do it right now. You end up having the grind on the pump tops case and this lever right here. Sometimes leaving it cut off to get this thing to retract even further, because what will happen when you get into like these extreme self-modded pumps, the THD pumps, it had both sets of starts and stops in it. It's a different story. It's benched and flowed and calibrated to that. When you're just doing this yourself, usually both your stops come out, your idle stop, throttle stop, and to get more fuel metering through in the thing, what you're gonna end up doing is taking this all the way out, and you'll notice that if it will bottom out, and there's only so far back you can go, what you can do, if you're very careful, remember these things run away, is cut this down, and then you can do the grinding on the linkage, or you can do some clearancing here to get this thing to travel further back. Actually, I think you just take this, sorry, this is gonna slide. Actually, don't even mess with that, just kind of grind it versus messing with your cog setup, because if you change that, it's gonna change the other position. But that's an old school trick that we used to do to pull more RPMs on them and pull on the governor spring harder to keep it fueling, like if the thing's under load and not running up through the RPMs real fast. And when we want to pull on those gov weights real hard, we can get this to come back further, so we can have more metering in it, as well as get a bigger sweep going this direction, because we can get the cog setup jacked even more. Remember, I would highly recommend that if these two mods, the ones that we've kind of talked about so far, not to do unless you are okay with either wrecking the engine or wrecking the injection pump. We're going to take the pump top off. There is 2 Allens here, 2 Allens here. A long ball end works perfect for grabbing these. If you got a good quality ball end, Allen wrench, you won't break it. Stick the ball end down here, put a combination wrench on it, and pop it loose. But really note where this was, at least so you come back in the general vicinity of where it was. And when you make sure you pull up on them while you're wiggling and pushing down. There's a spring with plastic bushing and some washers that go on here. We weren't going to go that extreme as far as getting all that stuff out. So when you take this thing out, carefully push the throttle arm down. And your pump top is up. This is our throttle arm. This is what has the indexing on it. There's a shim down here, just a friction shim. In the truck, you want to be very, very careful that you don't drop what we first geners call the top hat. Typically what I'll do is we'll take off the arm first in the truck and keep one hand on something at all times. Even here, we gotta be careful. And come back and we'll pop the spring out. And with pressure on this, carefully remove what we call the top hat. It's just a little spring-loaded device, very lightly spring-loaded, probably more than likely for any kind of oscillations that probably happen with the governor system, so the thing doesn't idle radically. So we're going to put this back in. Actually, I can move it out, it's fine. Just going to be careful. So the pump top's off. We can go over, let's go over this guy. We'll do this. So these are your governor weights. Yeah, we'll put the arm back on. It does make more sense with the arm on. Just be careful while doing this stuff. You don't want to drop any parts in here. Okay. I can't. So I call them the banana weights, but they're just your fly weights, your governor fly weights. It's probably pretty hard to see in here, but they're shaped like a banana. And what happens is when you pull the throttle, you're pulling on a springed system. So you can go wide open, and even though you're wide open, the governor weights can still pull back. So that limits how much fuel can be put in. So as the thing speeds up, say it has a stock or a 366 spring in it, as it nears 3200 RPMs, it starts to defuel itself. So that's why when we talk about the defuel rate, yes, you might have a 3200 spring, but the defuel has to begin somewhere. It's a curve. So when you pull it to wide open throttle, it goes through how many cc's it can do, and then as the thing's speeding up, it's starting to come out because it's a weighted system. So say at 2800 RPMs, it's starting to pull fuel back. You might be wide open throttle and things still might be screaming, but the thing's attempting or going to start to slow itself down by reducing the fuel quantity that's being injected into the chamber until it gets to 3200, where it's completely balanced itself out, where at 3200 RPMs, this thing's speed is at a point where there's not enough fuel being put in the chamber to make any more horsepower than it takes to only go what 3200 RPMs is worth of RPM. So that's how that works. So it's a curve. It begins the defuel rate far before at least a medium amount of distance from the actual governor spring, and that's why we often hear that the 3200 spring works really good, but there's the 366, the 3800, the 4200, the 4800 spring. So that's why there's those different things. But just because it's a 3200 spring doesn't mean it's only good for 3200. Like we talked about before, we can do linkage and throttle indexing mods to pull on the 32 spring harder to get more RPMs out of it than 3200. So it's rated at 3200 RPMs based on a factory amount of throttle arm pull. When we change how far the throttle arm gets pulled, we change what the governor spring can go up to, because it has a spring rate. The farther it gets, the tighter it gets. So when we pull on it really hard, it pulls out farther. I don't think I can actuate the flyweights while pulling on this, but that's essentially what they do. There's a rod in the middle that all four of these weights will push on to push your throttle back the other way. And this is just the gear drive that drives that at its calibrated speed. Obviously we can't mess with that or change it. So I guess we should talk about how a VE kind of gets its fuel pressure. VEs do run on a low fuel pressure amount, but we kind of think of them as how a CP3 or a VP works, where it's probably the best, yeah, I mean the VP works the same way, but it's a stage system. The fuel comes in through the inlet at 10 to 15 psi, but there's an internal vane pump that looks just like a power steering pump that then jacks the pressure up to between 300 and 600 psi. That 300 to 600 psi is then fed to the fuel galley, which is down at the lower section of the pump, around called the distributor head, which is this head here at the back. And actually I think it comes through this port here. That's how the fuel shutoff works. It blocks off that speed port. And as the rotor openings, the slots in the rotor called spill ports, come around, that pressure is needed to get the fuel into the plunger area fast enough, because you got to remember this is one plunger operating 6 cylinders. So this thing is moving extremely fast, so we need to operate at a high pressure to get the fuel into that spill port fast. So a mod that you should not do, but if you don't really care about anything, or it's something that if you break it, it's okay if it sits and you got to spend $2 grand or whatever on a new pump or you get calibrated, is this little dealio here. This little guy here sets case pressure. You can move this thing down maybe a 1/16 of an inch. You got to be really, really careful, because the only way they get it back is to remove it. These things you cannot buy, to my knowledge. I don't think you can buy them. That was loose. I've seen videos on YouTube of people repairing them, or at least attempting to repair them, because of how rare these things can be. I could be totally wrong. These might be totally available. It might only be the VE30s that have issues with these, but this is a regulator valve, and it regulates the case pressure. So by moving this down and putting more pressure on the regulator spring, that case pressure goes up, and it should, in theory, allow you to fuel or maintain CCs, a higher CC rate to a higher RPM, because we're not running into the issue of there's not enough time for the rotor to refill between injection events. This is our KSB, or hot start. What did it even talk? It's the German name for it is so long complicated to say, I have no idea how to tell you about it. But this thing is a timing advance for when it's cold. There's a wax pellet in here that, based off the fuel temperature / outside temperature, will melt or solidify. When it melts, it allows a contactor to contact, and it diverts. It's a pretty neat system. There's a video of a guy that totally disassembled one that was no good because the cam was trash, that really goes over it. But what this feed does is it feeds actually through here, and there's a machined port that you would think that it looks like it feeds pressure to this side, but the piston actually travels to this side. If you ever take this off, this is the dynamic timing advance. And what it does is there's actually a machined hole in here that comes all the way over to the other side of the injection pump, and it'll feed case pressure prematurely all the way to the other side and behind the piston, and push it this direction when it's cold. So we're talking about how the KSB works, and how it basically it doesn't make sense at face value that the fuel, the high pressure fuel comes out of the valve. There's always high pressure fuel coming through here. The valve just doesn't get opened until it's commanded to. This is what warms the element on this side. The attachment, you can hijack it with a switch. Honestly, haven't seen anything on the dyno that says it makes more power with timing advance. Somebody did do it and figured out how much timing advance there is. When this is active, it's not a lot. And there's on intercooled trucks, I do believe if you hijack it for too long, you'll ruin the KSB itself. So you're better off just not hijacking it. This whole thing works just fine. You don't get more advance over the OEM advance because the piston, regardless, the timing advance piston bottoms out in this casing, whether or not this is on or off. If you do need more timing, just in general, if you feel like you need to use this, just rotate the pump. You're gonna avoid a ton of problems. So we're probably gonna end part 1 right here. There's probably plenty of footage. We got all kinds of stuff to go over, but we will go over what we did talk about. We went over how to get the pump top off. We went over the inlet, the vane pump, the governor system. We went over basic mods where you can just move this ball to the inside spot, as well as some complicated mods as far as increasing case pressure and doing indexing work on the linkage. Those are mods that should be done very, very carefully by somebody that knows what they're doing, as well as someone who's not worried to destroy an injection pump, which this can cost upwards of $2,000 or more, depending on how extreme you want to go in horsepower or what your local place will do it for to repair and then modify. We went over, so you haven't gone over shut off, pump lock. We talked about the keyway a little bit. We can talk about that more. Basically, just put the motor where the keyway is facing up. These usually don't ever fall out, but they can. If you take the thing out at TDC, this is actually going to be facing at a downward angle. And if you pull the pump out, you can drop this into the motor. It only goes one way. Put the thing straight up, pull it out, do not move the engine, put it back in exactly where it was. You will probably have to, after the thing gets rebuilt, probably have to move this a little bit, but just line this back up with the gear, put it back in. So if the thing is locked, we're gonna unlock it. We talked about the DVs, how there's a difference in thread pitch and difference in size internally. We talked about how to take this off. So this we can next go over maybe, I guess we got linkages, metering screw, smoke adjustment, pin, factory pin, aftermarket pin, how to do easy mods as well as complicated mods there. So we'll go over that in part 2. We got over the KSB. Timing advance, we can actually get more intricate. Timing advance piston, we can actually see the cam plate that lifts the plunger. We can go over all that stuff with close-up shots in part 2, in part 3, and part 4, and however many parts it takes to properly go over a VE44 injection pump. So thank you for watching part 1 on understanding the VE44 injection pump. It does come on 89 to 93 first-gen Dodge diesels, as well as quite a few agricultural applications from generators, which we, in the diesel world, will call gensets, and small like tugs, and like I call them mini semis that move the semi-trailers to different locations. They can come on all kinds of things, tractors, you name it. But this is mainly focused toward the one that came on the truck. So thank you for watching. Remember, check out our website, instaspoolperformance.com, for our super cool swag, awesome shirt, and other awesome products that we make for 89 to 07 Dodge trucks. As far as oil covers, turbochargers, shock tower delete plates, our shirts, gauge bezels. I mean, there's all kinds of cool stuff on there, so let's be sure to check that out, as well as our other videos. Thank you for watching, and don't forget to subscribe, hit the like button, and ring the bell for notifications. Comment below if you got anything you want to add to this part, or stuff you want to see in upcoming videos. So said that we're going to fully go over the VE44 to my fullest understanding, then we'll move to the next generation of pump, to the next generation of pump, and then to the next generation of injection systems. Because I can't tell you perfectly how a column system work. We focus 89 to 02, but we do some parts for 03 to 07. So thank you and have a good night. And I know the fucking thing. Dude, calm down. Calm down.
Okay, start over.